Hello and welcome to your long COVID transformation. I'm your guide Betsy, and today I am talking about why we keep having so many new vaccines coming out for the COVID virus infection. So let's get started. First, I want to talk about the differences between viruses and bacteria, because understanding this helps you to make a better sense of how the vaccines work. First, it's important to know that viruses and bacteria are not the same. And that distinction really matters, especially when it comes to how our immune system responds and how the vaccines are designed. Viruses are more like hijackers. They can't survive or reproduce on their own. They need to invade your cells and take them over in order to make copies of themselves. Bacteria, on the other hand, are full living organisms. They can grow and multiply all by themselves, and they come with their own complex structures like cell walls, which gives our immune system more to target. So when your body is fighting a virus, it looks for things like viral proteins, like the spike protein on the COVID-19 virus. With bacteria, your immune system might go after toxins they produce or structural elements like that cell wall. Understanding these differences helps to explain why there's such a wide variety of vaccines and why there is no one-size-fits-all solution. So let's take a look at these and how the vaccines actually work. So we're going to go into the world of viruses and bacteria. And don't worry, we're not going to do the Osmosis Jones thing. And if you have no clue what I'm talking about, please don't comment on it. I don't need people trying to make me feel old. I refuse to grow up. Anyway, let's start with the viruses. They're unique. Like I said earlier, they cannot replicate on their own. They have to hijack a host cell in order to multiply. And unlike bacteria, they don't have a cell wall, and this makes them much trickier to target. So now we have bacteria. Fully independent organism, can survive and reproduce on its own. And like I mentioned earlier, they have specific structures, cell walls, and toxins that we can target with vaccines. This distinction is so important because it helps us understand why vaccine strategies are different for viruses versus bacteria. Each one requires a unique immune response. How do you think your immune system knows how to respond to these very different kinds of invaders? Next, we're going to explore exactly how your immune system detects and responds to these threats and how that leads to targeted protection. So, as we start exploring the immune system's targets, it helps to first understand how our body responds differently. So when it comes to a virus, our immune system typically zeroes in on something called spike proteins. These proteins are the key to how the virus attaches to and enters our cells. So targeting them helps to stop the virus before it can spread. That's why you hear so much about the spike protein with COVID. It's a critical piece of the virus, and it's one our immune system can learn to recognize. Now, with bacteria, the strategy changes. Instead of spike proteins, the immune system focuses on toxins that bacteria release, or structural elements like cell walls, features that are unique to bacterial cells. These differences explain why we need different approaches for protection. A vaccine designed for a virus wouldn't work the same way against a bacterial infection. And the same goes the opposite direction. Next, we're going to look at how this knowledge guides vaccine design and how these vaccines help to train your immune system to respond with precision. So as we move into our next topic, let's take a minute to focus on something foundational, which is, the importance of vaccine design. When we're talking about viral vaccines, their main goal is to block the virus from entering our cells. That's crucial, absolutely crucial, because if a virus can't get inside your cells, it can't replicate, spread, or cause damage. So, by targeting structures like the spike protein, viral vaccines help our immune system recognize and neutralize the threat before it has a chance to take hold. Now, when it comes to bacterial vaccines, the strategy is neutralizing the toxins that the bacteria produce. Those harmful substances that cause illness even after the bacteria are gone. Targeting the toxin helps stop the disease process at its source. Recognizing these different approaches helps us appreciate just how intentional and strategic vaccine design really is. It isn't just about fighting off an infection. It's about stopping it before it has the chance to do any harm. Now, we're going to take a closer look at how these design principles show up in the different types of vaccines, especially with the innovations we've seen in response to COVID-19. So, as we move into the topics of antibiotics and vaccines, let's start by clearing up a really important point. Antibiotics do not work on viruses. It's a common misconception. Antibiotics are designed to fight bacterial infection. They have no effect on viruses. They work completely differently because of how viruses and bacteria are different from each other. So when it comes to a virus, we turn to a different tool, the vaccine. Vaccines help to prepare our immune system to recognize and fight off specific viruses before they can make us sick. Think of them as a shield. It arms your body with the information it needs to respond quickly and effectively. And remember, prevention is always better than cure with a virus. Vaccines don't just protect individuals. They help build herd immunity, creating safer communities for everyone, especially the most vulnerable and the people who, for some reason or other, can't get the vaccines. Another thing to keep in mind is, unlike bacteria, viruses are always changing something, especially those lovely little spike proteins that the vaccine identifies. That's why they recommend a different flu shot every year. The flu virus, especially, is always changing something. It's like that home decorator or the gardener who just can't leave a beautiful canvas alone. They've got to add something new all the time. That's a virus. So it changes something, and the vaccine that already is preparing you to fight off the previous version doesn't do anything for the new one because it doesn't recognize it. Now, in the next section, we're going to explore the different types of COVID-19 vaccines, including a little bit of the science behind the mRNA, the viral vector, protein-based, and inactivated vaccines. So get ready to dive into some fascinating innovations in vaccine technology. And don't worry, I promise I won't get too technical for you. Especially because biology was not my first life. That was chemistry. So as we transition from understanding the importance of vaccine design, let's take a closer look at the different types of COVID-19 vaccines available today. We'll start with the mRNA vaccines. These include Pfizer and Moderna. These vaccines teach your cells to recognize the virus's spike protein. They don't contain any live virus. Instead, they give your body the instructions that it needs to respond quickly if you're ever exposed. It's the teacher. One more thing to note, the mRNA vaccines need to be stored at very low temperatures, which added some logistical challenges early on. Next, we have the viral vector vaccines like the Johnson & Johnson one and the one from AstraZeneca. These use a harmless virus, not the COVID virus, as a delivery system to carry the instructions into your cells. For example, the Johnson & Johnson vaccine uses AD26. It's a human adenovirus, aka a cold virus, that has been modified so that it can't reproduce or cause illness. And this particular one has been studied and used a lot over the years. One of the vaccines it is used for is the one for Ebola. All it does is acts as a messenger. It takes the message from the teacher into your body so that your body can recognize and respond to the virus safely. A key benefit here is that some of them, like Johnson & Johnson, only require a single dose, which makes them especially helpful in fast-moving vaccination efforts. Now we're going to talk about the protein subunit vaccines, such as the Novavax. These vaccines use purified pieces of the virus, like the spike protein itself, to trigger that immune response. They don't include any live virus, and they tend to cause fewer side effects, which can be reassuring for some individuals. Finally, we have the inactivated and live attenuated vaccines. These are more traditional and well-studied methods. Inactivated vaccines use a killed version of the virus, while the live attenuated vaccines use a weakened form. Both can build strong immunity, though live attenuated vaccines really aren't suitable for someone with a weakened immune system. So, to recap, mRNA vaccines instruct your cells directly. Viral vector vaccines deliver those instructions using a harmless carrier virus. Protein subunit vaccines use specific pieces of the virus to safely trigger immunity. Inactivated or live attenuated vaccines use the whole virus, killed or weakened, to build protection. Now, one thing to note on all of the vaccines, vaccine injury is a real thing. It has not been proven to cause long COVID in every case. I've heard from a lot of people who have not had any of the vaccines and they have long COVID. If there is a connection, it hasn't been found yet. So the issue there is everyone shouting at the top of their lungs that the vaccine caused their long COVID is they are taking attention away from the people who truly do have a vaccine injury. It isn't as common as long COVID, but it can result in very similar issues and is a very real problem. So now that you have the big picture, let's dive deeper into how the mRNA vaccines work and why they've been such a breakthrough in vaccine development. Now that you've got the overview, let's dive deeper into how the mRNA vaccines work and why they represent such a breakthrough in vaccine science. As we dive into the mRNA vaccines, such as Pfizer and Moderna, let's highlight how they work first. These vaccines teach our cells to produce the spike protein found on the surface of the virus. This method is innovative and highly effective, but it does come with a requirement. They need to be stored at very low temperatures to maintain their efficacy, in other words, to work. So it's crucial for us to understand that this technology represents a significant advancement in vaccine development. It's a pretty new thing. So to recap, mRNA vaccines educate ourselves. They're the little teacher. They require cold storage and show a cutting-edge approach to combating COVID-19. As we move into the next vaccine type, we're going to talk about viral vector vaccines, specifically Johnson & Johnson and AstraZeneca's vaccines. So these vaccines use a harmless virus, not the COVID-19 virus, to deliver genetic instructions to your cells. They're the messenger. The messenger takes the instructions, the message of the teacher, into your body so that your immune system can learn and be ready to respond if it encounters that real virus. One of the unique advantages of some viral vector vaccines like Johnson & Johnson is that they're designed to be effective with just a single dose. That's a big deal when it comes to accessibility and speeding up vaccination efforts, especially in efforts where follow-up doses might be harder to schedule. So as we continue learning, keep in mind the convenience and impact of a single dose vaccine and how that can shape real-world vaccination strategies. You too can talk about science, right? Up next, we're going to look at the protein subunit vaccines, which take a very different, but to me, very fascinating approach. So, we're talking about the protein subunit vaccines, like the Novavax. These vaccines work by introducing just a small recognizable piece of the virus to your immune system. So, going on with the education analogy, it's taking like a little bitty snapshot of it and showing it to your body so that your body knows how to recognize it without ever being exposed to the full thing. Now, the standout benefit of this is that the protein subunit vaccines tend to cause fewer side effects, which makes them a reassuring option for people who may be more sensitive to other vaccine types. That's me. I am not getting either of the other two ever again. The last one that I got triggered a very bad crash, and I also wound up sick for a couple weeks, I think it was, because between the crash and everything else, something glanced in my general direction and I got it. So, the protein subunit vaccines are built on a well-established and traditional vaccine platform, which means that the vaccine type has been studied and used in medicine for decades. And this gives us a very solid foundation of knowledge about their safety and effectiveness. So this approach not only helps your body build immunity, it does so with a track record of low side effects and strong safety. Next, we're going to look at other proven and effective vaccine methods, each with its own unique role in protecting public health. So, taking a closer look at another category, which is the inactivated and the live attenuated vaccines. These vaccines have also been around for decades and are well established and effective. They work by using either a killed virus, which is the inactivated, or a much weakened version of the virus, which is the live attenuated vaccine. And this stimulates an immune response without causing illness in healthy individuals. So that said, it's very important to remember live attenuated vaccines may not be suitable for people who are immunocompromised, because even a weakened virus could pose a risk in those cases. I would actually go a little bit further to say may not be suitable and replace that with no. That said, it's important to remember a live attenuated vaccine, even though weak, can give someone with a weakened immune system, in other words, somebody who's immunocompromised, the virus, the illness, and it would be risky. In my opinion, this means they would be not appropriate at all for someone with long COVID. Your immune system is still in that fight or flight mode, and it's overreacting to everything it comes into contact with. And it also highlights why the diversity in vaccine technology matters so much. Different pathogens and different people require different approaches. The more we understand these methods, the more we appreciate the thoughtful science behind them and why no single vaccine works for everyone or every situation. So up next, we are going to explore how this variety in vaccine design plays a role in protecting public health across different populations and conditions. So as we explore the diverse landscape of vaccines, let's take a moment to focus on a powerful concept. More than one path means more than one vaccine. This simple phrase carries a very important message. It reminds us again, there is no one-size-fits-all solution when it comes to protection. Each vaccine is designed to work in a unique way, giving us different options depending on our individual needs and circumstances. Key point 1. More vaccine options means more opportunities for effective immunization across a wide range of people. Different vaccine types can engage different parts of the immune system, and some are better suited for specific groups, whether it's based on age, health status, or access. Key point number 2. I've said it before, but it bears repeating. Knowledge is protection. The more we understand about these different vaccine pathways, the better equipped we are to make confident, informed decisions about our health. Understanding these diverse approaches doesn't just help us protect ourselves. It empowers us to advocate for our communities too. So let's keep this momentum going as we prepare to wrap up and talk about how you can stay engaged with this vital information moving forward. First, share this video. Share this platform with everybody you know, whether they have long COVID or not, because everyone needs this kind of information, in my opinion. So that's what I have for today. Thanks again for joining me. And if you're ready to keep learning, I would recommend you watch Understanding Your Symptoms Next. It's a helpful guide to making sense of what your body is telling you and how you can take the next step towards healing. Spread joy, not germs. Betsy out.